Okay, hello everyone. Welcome into our final lesson of unit number 4. This one's going to be about how we problem solve with permutation and combination, okay? So when we get to this section, they're all going to be mixed together. So the first thing we want to do is just identify whether we're dealing with a permutation or a combination. So remember, a permutation is an arrangement of objects with regard to order, okay? So the order matters. Okay, a combination is a selection of objects without regard to order. So order does not matter. Not matter. Okay, so if we have a specific order that we need everything in or specific roles, then we're going to be using a permutation and follow those rules. And if there's no order, it doesn't matter about our arrangement, then we use a combination. Okay. So when you have the moments together, that could be in your assignment or your test, the first thing you want to do is determine whether you're dealing with a permutation or a combination, and then solve using those strategies. Okay. So if anyone's ever seen a BBC version of Sherlock, there's one episode where he's looking at a phone to try and unlock, and it says "I am." There's 4 spaces locked. It goes "I am locked." Okay. So would this be a permutation or a combination? Okay. Just like your regular combination locks at school, they're not actually combinations, they're permutations because the order matters. Okay. The specific, in this case, letters that go into here, they matter. And it was actually I am SHER, because I am Sherlock. Because Sherlock Holmes is kind of fun. But like the order matters here because if you wanted to do a combination where the order doesn't matter, you'll do ERSH, and that would also unlock it. But this doesn't work because it's a specific order that you need in. So that's how we know that we're dealing with a permutation rather than a combination. Okay, so if the order matters, permutation, no order, no specific rules, looking at a combination. Okay, so first, how many 4-digit numbers have at least one 5 in it? Okay, whenever you're dealing with like any kind of number problem like this, where you're looking at 5 in like a specific spot, that's going to be a permutation. Okay, so how did we solve this? Well, oh yeah, and this is because the order matters. So it matters where we have that 5 and how many 5s we have, okay? So have at least one 5. I'll break this down to different colors. At least one means that you could have could have 1 5. Oops, sorry. Just to avoid confusion, I'll write out the numbers of numbers here. You could have 2 5s. You could have 3 5s, or because it's 4-digit number, we could even have 4 5s. Okay. So how do we solve it? You could either do it directly, where we have, if we're saying 1 5 in it, remember we have our restrictions down here and then the number of options down here. So we could have the 5 in this spot, and then it doesn't matter what's here. We could have the 5 in the second spot. Then it doesn't matter for the other ones. We could have the 5 in the third spot. It doesn't matter. Or you could have the 5 in the last place value, 5. So you multiply everything in the middle here for all of them, and then add them all up. So that's if we have 1 5. Then if we have 2 5s, it could start off 5 5. Then could go 5, any number, another 5, any number. It could have 5 at the beginning and end of the number. But then you could have 5 in the second spot, and 5 in the third spot. Okay, this keeps going on and on and on. Okay, this would take a lot of time, and it's a lot of it's a long procedure. So Whenever we have at least here, what we're going to use is what's called the indirect method. Oops, sorry. Indirect. Actually, let me just erase it. Make it. I already have bad handwriting as it is. Indirect method. Okay. So what we're going to do is we will do the total minus the opposite. Okay. So like for this specific case, if we want 4-digit numbers that have at least 1 5 in them, what we can do is find the total number of 4-digit numbers. And then we're going to subtract when there's no 5s in here, okay? Because if we look at all of the 4-digit numbers, and then we just take out any number that doesn't have a 5 in it, then whatever's left must have at least 1 5, okay? So we do the total number of possible 4-digit numbers and subtract when we don't have a 5. Okay, that's the indirect method because we're not solving directly how many each have a 5. We're saying how many don't have a 5, and then let's take that away from the total. Okay, so a lot of the times it makes it a lot easier to solve because you have to do fewer calculations. Okay, so if the number doesn't have a 5, it'll have 0, 1, 2, 3, 4, 6, 7, 8, and 9. Those are the potential digits that you can have. Okay, so we have 9 potential digits here, but remember we just have to take into account for that 0. Okay, so how many total options do we have? Remember, I'm going to put my restrictions on the bottom and my number of options at the top. So the only restriction that we have is that we can't have 0 in the first spot. Okay, because if we have a 0 here, it's going to be a 3-digit number or a 2-digit number or a 1-digit number. Okay, so if we say we can't have 0 here, then for our total, we could have 5, right? We'd have 0, 1, 2. Oh, wait, that's the wrong spot. I didn't want to do that arrow there. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are the total number of options that we have, and then we'll subtract when we don't have a 5. So if we can't have 0 here, we still have 9 digits that we can use. Then for the second one, it could be 0, doesn't matter. Same for the third and the fourth spots, okay? Because if we don't have 0 here, that means it's not going to be a 3-digit number or less. And then 0 can be here, 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 because we can have like 1,000. That's a 4-digit number. But 0, 4, 8, 5 would just be 485, 3-digit number. Not what we are looking for. Now, it's going to be similar when we don't have a 5. We can't have 0 here. And we also can't have 5. So we're down to 8 potential options for that one. And then our remaining 3 slots could be any number of these 9. So we have 9 options, 9 options, and 9 options there. Okay, so that will be equal to, so I'm kind of running out of space here. 9 times 10 times 10 times 10 would be 9,000 minus 8 times 9 times 9 times 9. Put that into your calculator, you should get 5,832, which means that there are 3,168 ways. Okay, so that means that 3,168 4-digit numbers have at least 1 5 in it. Okay, so we took the total number of numbers and just subtracted when we don't have a 5 in the number. Whatever's left must have a 5 in it necessarily. Okay, we'll do a little bit more with indirect methods in just a moment. Okay, yes, I am still in the call. Thank you. Okay, so our recent data party, that's what the cool kids do. They go to data management parties. There are 6 females and 5 males present. Since this group meets regularly, they want to select 4 people to lead the study session every week. Okay, and how many different ways can this be done if there's no restrictions? Now, remember, there's no specific roles. Therefore, we have a combination, okay, because the order does not matter. Okay, so if there's no restrictions, how many total people do we have? Our N is 11, and we're choosing, because it's 6 females, 5 males, and then we want to select 4 people. That will be our R. So if there's no restrictions, we have 11, and we're choosing 4. Okay, and that is equal to 330. Okay, so it's 330 ways. Okay, remember on your calculator, calc, it looks like 11, oops, just an H, 11, then you have that NCR button, and then we'll have 4. Okay, and that should get you 330 on your calculator. Okay, in B, same setup, but this time Dan or Nick can be selected, but not both. Remember, when we have or, that means that we're going to add things together, okay? Remember, when we had and, it was multiply. When it's or, we add, okay? So it's still a combination, this question. Okay, so either Dan or Nick must be selected, but not both. So we have to have one or the other, but we can't have both of them together. Okay, so we're still doing combination because there's still no specific roles. But what we want to do is look and see when Dan gets selected. So if Dan is picked, that means we have one, choose one, because we know that Dan has to be there. So there's one Dan, and he gets picked for sure. Okay, and then how many people can we select from? You might say 10 initially, but actually we only have 9 options left because we can't have Nick. No, Nick. Okay, because if Dan is picked, we can't have Nick. Okay, so if Dan's picked, we have one Dan being picked out of 1, and 9 choose 3 because we can't have Nick. Okay, and then we add that to when we have, actually use a different color. When we have Nick, that would be, again, 1 choose 1 because we have one Nick to pick from. And then, so Nick already got picked, so that lowers us down to 10 people. And we can't have Dan as well. So we're down to 9 potential people that we can choose from, are 3. So it's 9 because no Dan, and Nick is already picked. Okay. So what we end up having is like 9 choose 3 and 9 choose 3, or like 1 choose 1 times, remember they're being multiplied here. So that would just be 1. This would be, I believe, is 84. Plus, we'd also have 84 from this one because that ends up being the same number. Since we're multiplying the same 2 things together. This means we have 168 ways of choosing this committee if we want Dan or Nick, but not both of them. Okay, so a lot of times, like those be names there, it doesn't matter what the names are or who the people are. We're just looking for that one choose one there. Okay, and then we subtract 1 from our total that we have left because we can't choose Nick. Okay, now if we want to do this, but at least one female selected. Okay, still a combination. Don't have any roles yet. But to solve this, I'm going to do both ways. I will do the direct method and indirect method, just so that you can see how if you're just looking for at least one, the indirect method is often a lot faster. Okay, so direct method. Okay, so there's 4 people total in the committee. So we can have 1 female. We could have 2 females. We could have 3 females on the committee, or we could have 4 females. Actually, I might move that one down just a touch. Move them all down just because I want to have little bit of label at the top. 2 females, 3 females, and 4 females. Okay. And then I'm going to separate them into the females that we're choosing from and the males that we're choosing from. Okay. So how many total females are there? There's 6. So we'll have 6. And for this example, we're only picking 1. So we have 6, choose 1. How many males do we have? We have 5 males. And if we pick 1 female for the committee, that means there's 3 other roles that we can have left. So for the males, it would be 5, choose 3. Okay, so 6, choose 1 times 5, choose 3 is 60. Next, if we have 2 females, so we just have to go through all the possible combinations when we have at least 1. So we see when we have 1 female, how many ways are there? If there's 2 females, there's 6 females to choose from, and we're choosing 2. And we still have 5 males that we can choose from, but this time we chose 2 females. So there are only 2 males left to choose from. If we were to have 3 females, it'd be 6, choose 3, and 5, now only choosing 1 because there's 1 spot left. If we have all females, it'd be 6, choose 4, and we have 5 males, and we're choosing 0 of them, okay? And anything choose 0 is always just going to be 1. Okay, so just 6, choose 2 times 5, choose 2 would be 150. And then we have 100, and then we'll have 15. Okay, so what we're doing here is we're looking in the direct method. If we have 1 female, or if we have 2, or if we have 3 females, or if we have 5 females. So remember, that or means that we have to add all these up together. Oops. Do a better line. So what we're going to do is we're going to add all these up. So 60 plus 150 plus 100 plus 15 will be 325. So there's 325 ways that we can have at least 1 female on the committee. Okay, so that's a direct method, which if you find this easier, you just see when there's 1, when there's 2, when there's 3, when there's 4. It's totally okay if you do the direct method. But I also want to show you the indirect method because whenever we have at least 1, indirect is going to be faster. Okay, so what we're going to do is do the total and then subtract when we have no females. Since we're looking for at least 1 female in the committee, if we have no females and we subtract that from the total, what's left must be when we have at least 1 female in the committee. Okay, so remember, we just did the total in part A. We have 11, choose 4, because there's 11 people. We're choosing 4 for the committee. And then here, we'd be having 6 females, but we're not choosing any of them, times when we have 5 males, and this time we're going to pick all 4 from the males. Okay, so that equals 330. Again, minus 6, choose 0, times 5, choose 4 is 5. So our indirect method gives us 325 ways. Okay, so both methods work. You get the same answer for both of them. It's just a matter of personal preference for lower numbers like this. If you're only choosing 4, it's easy enough to do the direct method. But when if you have like a 7-person committee, it might start to get a little bit longer. So that's when indirect method would probably be easier. Okay, question number 3. And how many different ways can 8 books be arranged in a row on a shelf if the data and calculus textbook cannot be adjacent? Okay, so remember, these are similar to permutation questions we already did before, okay? These are permutations because the order on the shelf matters. Okay, so remember, if we have 8 textbooks on the shelf and we just have data and calculus, or 2 of the textbooks, and they can't be adjacent. So we have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 books on the shelf. Okay. Now, what we could do is we can look and see, say this is my calculus, and this is my data. We can see when this one's here, 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 and here. Then move this one over. Then it can still be here, 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 here. Move this one over. Then it can be here, 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 here. There's a lot of different ways, but the way to solve it that's fastest is actually indirect. Okay, so if we find the total number of arrangements, then we can just subtract when data and calculus are adjacent. Because whenever they're together, see if I were to put these two back there. Whenever I have these two together, if I take that away from the total number of arrangements, whenever they're together, if I subtract that from the total, what's left must be when they're not together. Okay? Remember, we've already done questions similar to this where we move things around in a way to see when they are adjacent. Okay? So to find the total, we just look at how many total books there are. We have 1, 2, 3, 4, 5, 6, 7, 8 books. So that's 8 factorial. There's 8 factorial ways of putting them together. And the factorial is kind of why it's more of a permutation. Because once we put, say, data here, it can't go anywhere else. Okay, so the spot on the shelf is important. That's why it's a permutation. Okay, and then we subtract when they're adjacent. So if we look at this, we have 1 unit here, 2, 3, 4, 5, 6, 7. So we have 7 total units that we're going to move around. And then within this box here, we have 1 and 2 within the unit. So it just allows for us, because say data could be first in calculus or calculus then data. And as they move through, they can always switch up their order. That's why 7 factorial times 2 factorial. Okay, so this would give us 40,320 minus 10,080, which gives us 30,240 ways. So there's over 30,000 ways to arrange those textbooks and not have data and calculus together, adjacent. Okay, sorry, if you weren't sure what adjacent means, that just means together. Okay. And now we just have one last question. So how many 3-digit numbers can be formed using the digits 1, 3, 3, 0, 4, and 8? Okay. So remember, when we have specific digits, you want to use them like letters. Okay. Now what we're going to do, sorry, just have to catch my breath there for a minute. So what we're going to do is look, we have 2 3s. Okay, we have 2 3s. Okay. And then since to make a 3-digit number, we only need to use 3 of the 6 digits. So we can make special cases. Okay. And we're going to use the direct method. Whoops. direct method. Okay, so we're going to kind of use these like letters like we're almost building a word, but that word is just a 3-digit number. And we're going to look specifically at our threes. Okay, these are going to be the key factor. Because if there are no restrictions at all, we could just, like, if these were all 6-digit numbers, then we could just go, we have 6 options, then we can use 5 options, then we can have 4 options. And then that would be if we had 6 different digits. But because there's 2 threes, we need to make special cases. Okay. So what we're going to do is we're going to look at cases when we have no threes. Okay. And that means the only digits we can use are 1. Sorry, we have 0, 1, 4, and 8. Then we're going to look at when we have 1 3, in which case we can use 0, 1, a 3, a 4, and an 8. And then we'll look at when we have 2 3s. Okay. And we're going to have 0, 1, 3, 3, 4, and 8 as potential options for our number or for our digits. Okay. So if we have no threes, the only thing we need to look at, our only restriction, will not be having a 0 in the first slot. So we can't have 0 here. So that means we have 1, 4, and 8. So we have 3 options that can go there. Then say if I put the 4 there, I can only use 1 and 8. So I'll have 2 options here. I'll have 1 option here. Okay, so 3 times 2 times 1. Oh, sorry. Oops. I forgot. Sorry, it won't be 3. It won't be 2, it'll be 3 because say if I use the 4 here, then I can use 0, 1, or 8. So I have 3 options here. So if I go 4, and then if I put 0 in the second spot, then I have either 1 or 8. So 2 options left here. So there's 18 different numbers we can make with those 4 options. Next, what I'm going to look at is if I have 1 3, let's say I put the 3 here, or I can put the 3 in this second spot of the number, or remember that means and, or that means addition. I can have the 3 at the very end. Okay, so if I have a 3-digit number with only 1 3, that means 3 either goes in the first place column, it can go in the second place column, or it can go in the last one. Okay, and then if I put 3 here, there's only one option because I know I'm putting 3 there. I know that I'm putting 3 here, or I know that I'm putting 3 here. So in this first one here, once I put 3 here, I can have either 0, 1, 4, or 8. So I have 4 options here. Then say I put the 8 there, I have 0, 1, or 4. So I have 3 options left. Okay. Here in the first one, remember, I still can't have a 0 for either of these. So I know I'm putting 3 here. I can't put 0 here, so I can have 1, 4, or 8. So I have 3 options I can put there. In my last row, I could have the 0, and I'll have the remaining options I didn't have. So say if I start the number with a 1, so it's 130, then it could be 0, 4, or 8, because it could be 130, it could be 134, or it could be 138. So I have 3 options left here. Then for our last one, I'll have the same 3 and 3. Just like I did here, it's moved over the 1. Okay, so that 0 is the reason why we have to kind of look at each specific case too. Okay, 4 times 3 is 12. 3 times 3 times 1 would be 9. 3 times 3 times 1 would be 9 again. So that would give us 12 plus 9 plus 9, which is 30. Now, if I have 2 3s, I can put a 3 in the first spot or in the last spot, or I can put a 3 at the beginning and a 3 at the end. Or I don't have to start with number 3, and I can end it with 33. Can I put these two 3s anywhere else? No, these are the only different ways I can arrange my numbers. So then I know that I have a 3 here, but I can use this 3, or I could use that 3. So I actually have two options here. Or sorry. No, let's make it easier. I know that I'm putting a 3 here, so that'll be 1. I know I'm putting a 3 here, also 1. How many options do I have left here? I have 0, 1, 4, or 8. So I have 4 options here. And then here, 1 and 1, and whatever's left in the middle. I have 4 options here. Still can't start the number with 0. Otherwise, I just have 33. So I have one option where I put each 3, and then I will have 3 potential options that I have here. Okay, so I have 4. 1 times 1 and 4 is 4. So I have 4, 4, and 3, 11 options. Then what I do is I add up all the ways that they can be arranged. Okay, so I have 18 plus 30 plus 11, which gets me 59 numbers. Okay, so there's 59 different 3-digit numbers that can be formed using these specific digits. Okay, so that's it for this lesson and it for this unit. We're going to be getting more into probabilities after this. But please, if you have any questions before your assignment or test, let me know and I can help you out. Okay, have a great day and we'll see you in Unit 5.